To my video on determining the y-intercept from a table, a verbal description, or an equation. So the y-intercept is where the line touches or crosses what axis? The y-axis. An equation written in y equals x plus b form provides information about the graph. If the equation is y equals x minus 1, then the slope m of the line is 1, or 1 over 1, rise over run. And the point where the line crosses the y-axis can be located at 0, negative 1. And remember, we looked at this when we were graphing. If it was ended with minus 1, then that meant that the y-intercept crossed at the y-axis at negative 1. So the ordered pair could be described as 0, negative 1. And notice the x value is 0. The y value will be the y-intercept. So let me say that one more time. When the x value is 0, the y value will be the y-intercept. So the y-intercept here is negative 1. So the y-intercept of this equation would be negative 1. We also know that slope equals m, and m equals change in y over change in x, which equals positive 1, up positive 1 over positive 1, or it also equals down negative 1 over negative 1, which equals a slope of positive 1. So let's review how to graph so we can see how this ordered pair is related. So y equals x minus 1, this is in y equals x plus b form. Even though this is subtraction, it's still in y equals x plus b form because we can add negative 1. Adding negative 1 is the same as subtracting positive 1. So we circle the minus 1, and that represents the y-intercept. So that means this equation is going to cross through the y-axis at negative 1 because the y-intercept is negative 1. So we're going to put a mark right here. Now, the number in front of the x is the slope, and there is no number. So we say that the slope is 1. So we can write this as m equals 1, and what number can we put underneath it? And it doesn't change its value? Good, a 1. And so we describe the top number as the rise, and the bottom number is described as the run. So we're going to go up 1 over 1, up 1 over 1, and continue that pattern of up 1 over 1 until you get to the edge of the graph. And now go back to the y-intercept, and now we have to go the other direction. So down negative 1 over negative 1. And remember, 2 negatives makes a positive. So that's why it still works, because our slope is positive 1. Down negative 1 over negative 1, and down negative 1 over negative 1. So use your ruler to connect the points and go a little bit past in each direction and draw your arrows. Now this point right here is the y-intercept, so let's label it. Draw an arrow to it, and we call that the y-intercept. And the y-intercept coordinates will always start with 0. So it's going to be 0, negative 1, because the x is 0, the y is negative 1. So this will always happen. When the x value is 0, the y value will tell you what the y-intercept is. So let's keep that in mind as we go through the rest of today's notes. So turn the page. A table of values can be used to determine the graph of a line. The y-intercept is located on which axis? Good, the y-axis, which is where the x-coordinate is 0, and that's what we were just talking about on the previous page. The change in each y value compared to the corresponding x value can be verified by the patterns in the table of values. So we're going to determine the y-intercept from the table below. And we already know that when the x is 0, the y value tells us the y-intercept. So if you look at this table, I see that the x is 0 right here. And that means the y value here is going to tell me where it crosses the y-axis. So it's going to cross at -7. Okay, so now let's look at the next example. How do you find the y-intercept when, and let's cross this out here. This is a typo here. How do you find the y-intercept when the x value of 0 is not in your table? So notice the x value of 0 is not in my table. So what do? I can do a couple different things. I can write the rule. And the rule or the equation comes from, how do you get from -4 to -6? How do you get from -2 to -4? -1 to -3, and 1 to -1. Do you notice how much they're going down by? Hopefully you notice that each one went down by 2. So the equation would be y equals x minus 2. And since the equation is subtract 2, look at the ending, and the ending will tell us that the y-intercept is -2. Now, here's another way you can do it, okay? If you look here to get from -6 to -4, it's +2. And to get from -4 to -2 is +2. So the slope would be 2 over 2. And what does 2 divided by 2 simplify to? 1 whole. And if the slope is 1, that means each x value, when it goes up by 1, the y value also goes up by 1. And look here to see what I mean. We have x value -4 and an x value of -2. That means I'm missing -3. And so if -3 is in between these two, then what's in between -6 and -4? Good, -5. So look, when the x value goes up by 1, the y value goes up by 1, up 1, up 1, up 1, up 1. And what comes after -1? 0. And what comes after -3 if I'm going up by 1? -2. So you see, 0, -2, the x is 0, the y is -2. That's another way that I can come up with a y-intercept of -2. So whatever way works best for you, I would suggest using that method. But remember, that pattern in the tables will only work when the slope is +1. They'll each be going up by 1. Okay? Okay, so find the y-intercept of the tables below. I don't see where x equals 0. So we can compare the x to the y and see if we can come up with the rules. So it's -3 to 0, -1 to 2, it's going up, 3 to 6, it's going up, 5 to 8, it's going up. What's it going up by? It's going up by 3. So y equals x plus 3. Since the ending is +3, that means the y-intercept is +3. So this would cross through the y-axis at 3. Now, if you're using the pattern, okay, remember, let's see, this goes up by 2, so 2 divided by 2. This does have a slope of 1, okay? So -3, -1, I skip -2. So 0 to 2, I skipped which one? 1. Okay, and notice if you do it correctly, the pattern will continue. So -1, 0, and 0, 1, 2, 3. I don't need to go any further because when the x is 0, the y is 3, and that number tells me the y-intercept. Okay? So let's look at number 2. This time, I see where the x is 0, the y is -4. So that tells me that this line crosses through the y-axis at -4. So the y-intercept would be -4. Now, if you didn't see that, you could certainly ask yourself, how do I get from -2 to -6, 0 to -4, 2 to -2? Probably the most obvious way to see it is from 5 to 1. So how do I get from 5 to 1? Subtract 4. So the equation would be y equals x minus 4. And then we could use that to come up with the y-intercept of -4. So both methods will work. And then we also have the pattern method as well, if you like that. So let's look at our third example. So x does not equal 0 in my table. So what we can do is see if we can identify what the pattern is. So -1 to 6, 1 to 8, 4 to 11, 5 to 12. So the x value is increasing by 7. So that means the equation would be x plus 7. And since I'm adding 7 to the x, that means that this number is the y-intercept, which is 7. Okay. Now we could also look at the pattern here. -1 to 1, we skip 0. And if this is going up by 1, then this goes up by 1, so it's 7. And remember, it's only they're each going up by 1 because the slope is 1 here. So keep that in mind. That's the reason why it's working. So let's turn to the final page here. So how do you determine the y-intercept from a verbal description? So we translated earlier this year, and so we first have to translate the equation. If it is in the form y equals x plus b, then the b is the y-intercept. So the questions below ask me, what is the y-intercept? So we have to translate the equation. And remember, when we translate an equation, remember that the word is means equals. So y equals 6 less than x. Remember, this is a switch around word. So instead of writing 6 minus x, I would write x minus 6. And this is in y equals x plus b. So that means the -6 is my y-intercept. So I would call the y-intercept -6 because it would cross the y-axis at -6. Okay, so let's look at number 2. Y is 10 more than x. So remember, is means equals. 10 more than, circle this. More than is a switch around, so instead of 10 plus x, I would write x plus 10. And since it ends, it's in y equals x plus b and ends with plus 10, that means it crosses the y-axis at positive 10. Okay, let's look at example 3. Y is, so that means y equals 8 more than x. So it's a switch around word. So instead of 8 plus x, I would write x plus 8. The ending is plus 8, so that means it crosses the y-axis at positive 8. So the y-intercept is 8. And the last one in this section, y is, so that means y equals 4 less than x. So instead of writing 4 minus x, this is a switch around word, and it tells me to write x minus 4. The ending is my y-intercept, so it crosses through at -4. So the y-intercept is -4. Now, we can use the strategy we just learned here because all of these are in y equals x plus b. So if we look at the ending, that tells us ends with -11, so that means it crosses the y-axis at -11. So the y-intercept is -11. And the last one, the ending is +7, so that means it crosses the y-axis at +7. Therefore, the y-intercept is 7. Now be sure, when I ask you questions, most of the time our strategy was to write the equation to come up with the y-intercept. So when I ask for the y-intercept, just put the number on the blank. You may have to write the equation to get the y-intercept, but your final answer, if I'm asking for the y-intercept, is a number. So also remember that when the x is 0, the y value is your y-intercept. So that concludes our notes on determining the y-intercept from a table, verbal description, and equation. I hope you have a great day.